You can't feel your own weight. Right now. Sitting there. Standing there. You think you can. You think you feel it pressing down. But you don't. You've never felt your weight in your entire life. Not once. And when you understand why, everything you think you know about gravity shatters. You've been told gravity pulls you down. That's just how it is. But that's not an answer. That's just repeating words. When you really ask what's happening, you discover something so strange it rewrites what it means to stand on solid ground. Feynman spent years teaching this exact problem. And once you understand it, you'll never trust the feeling of standing still again. Let me show you what I mean. You're sitting in a chair right now. You feel something. Pressure on your legs. Pressure on your back. You call that feeling weight. But here's the thing. That's not your weight. That's the chair. The chair is pushing up on you. Hard. Really hard. With a force exactly equal to your mass times 9.8 meters per second squared. That's what you feel. Not gravity. The chair. Think about it. You've never actually felt gravity pulling you down. You've only ever felt things pushing you up. The ground. The chair. The floor. Your shoes. Every single sensation you associate with weight is something stopping you from falling. Not the falling itself. Now watch what happens when you remove the push. Jump off a diving board. For those 2 seconds in the air, what do you feel? Nothing. Absolutely nothing. You're weightless. Not metaphorically. Actually weightless. But what's actually happening? You stopped feeling the seat pushing up. Gravity is still there. Still pulling. 9.8 meters per second squared. Exactly the same. But you feel weightless. Because you're not being stopped anymore. You're just falling. And falling feels like nothing. Here's where it gets strange. Let's go further. You're in the space station. Orbiting Earth. 250 miles up. You float. You spin. You push off walls. Everyone calls this zero gravity. But that's completely wrong. Dead wrong. The gravity up there is almost the same as down here. At 250 miles altitude, Earth's gravity is still 90% as strong. Still pulling. Still accelerating you at 8.8 meters per second squared. So why do you float? Because you're falling. The station is falling. You're falling. Everything inside is falling. Together. At the same rate. Toward Earth. Missing Earth. Falling around Earth. That's what an orbit is. Falling while moving sideways fast enough to keep missing. And what does falling feel like? Nothing. Weightlessness. Not because gravity is gone. Because nothing is stopping you from falling. Let me take you back. 1907. Bern, Switzerland. Einstein is working at the patent office. He's thinking about gravity. He's been thinking about it for years. And then it hits him. He called it the happiest thought of his life. Here's what he realized. A person falling from a roof doesn't feel their weight. They feel nothing. They're in free fall. And if you're in free fall in a closed box with no windows, there's no experiment you can do to prove gravity exists. None. You drop a ball, it floats next to you. You jump, you drift. Everything behaves exactly as if gravity is turned off. Not similar. Identical. This isn't an approximation. This is exact. Now flip it. You're standing in a closed box. You feel weight. You feel pressure on your feet. You drop a ball, it falls. It accelerates at 9.8 meters per second squared. Fine. But here's the question Einstein asked. Are you standing still in Earth's gravity? Or are you in deep space in a rocket accelerating upward at 9.8 meters per second squared? Think about it. If the rocket floor is accelerating up into your feet at 9.8 meters per second squared, you'd feel the exact same pressure. You drop a ball, the floor accelerates up to meet it. Looks exactly like falling. And here's the thing that broke physics. There is no experiment you can do inside that box to tell the difference. None. Einstein realized these two situations aren't just similar. They're the same situation. Exactly the same. Gravity and acceleration are identical. This is important. Let me say it differently. When you're standing on Earth, you're not sitting still being pulled down. You're being accelerated upward. The ground is pushing you up. Constantly. At 9.8 meters per second squared. But you're not going anywhere because you can't. The Earth is in the way. So you feel that push. That constant acceleration upward. That's what weight is. Not gravity pulling down. The ground pushing up. Wait, let me show you why this matters. Picture two people. One standing on Earth. One in a rocket in deep space accelerating at 9.8 meters per second squared. Both feel the same pressure on their feet. Both drop a ball and watch it fall at the same rate. Both experience exactly the same physics. Now here's what Feynman loved about this. The person on Earth says, "I'm standing still. Gravity is pulling the ball down." The person in the rocket says, "I'm accelerating up. The floor is catching up to the ball." Who's right? Both. Neither. It's the same thing. There is no difference. Not philosophically. Physically. Mathematically. The equations are identical. So let's bring this to something you felt. You're in an elevator. It starts going up. For that first second, you feel heavier. Your knees feel it. Your stomach feels it. You're being accelerated upward faster than 9.8 meters per second squared. Maybe 10.5. Maybe 11. The floor is pushing harder. You feel it. That's not an illusion. The scale under you would read higher. You weigh more. Actually way more. Now the elevator reaches constant speed. You feel normal again. Back to 9.8. Then it slows to stop at the top. For that 1 second, you feel lighter. Your stomach lifts. The floor isn't pushing as hard. Maybe only 7 meters per second squared. You weigh less. The scale would prove it. Now the key question. When did gravity change? Never. Gravity stayed exactly 9.8 meters per second squared the whole time. Earth didn't change. Its mass didn't change. The distance didn't change. So what changed? The push. The floor pushing up. That's what you feel. That's what the scale measures. Not gravity. The resistance to gravity. The thing stopping you from falling. And here's what breaks people's minds. When you're standing still on Earth, you're in that elevator. The elevator is accelerating upward at 9.8 meters per second squared. But the shaft is only as long as you are tall. So you don't go anywhere. You just feel the push. Forever. That's standing still. Constant acceleration with nowhere to go. Let me show you the proof. Astronauts in the space station. They're in free fall. Orbiting Earth. Falling around it. They feel nothing. Weightless. Now they fire the thrusters. Just a tiny burst. 0.5 meter per second squared of acceleration. Suddenly they feel weight. They drift toward the back wall. The wall pushes them. They feel pressure. They're not weightless anymore. Did gravity turn on? No. They're still in orbit. Still the same altitude. Same gravitational field. But now there's a push. The wall accelerating into them. That creates the sensation of weight. Turn off the thrusters. Back to free fall. Weight disappears. Instantly. This has been tested thousands of times. It's not theory. It's measured. Weight isn't gravity. Weight is resistance to gravity. And here's where it gets beautiful. Newton thought gravity was a force pulling you down. Einstein realized gravity isn't a force at all. It's the shape of spacetime. You're not being pulled down. You're following a straight line through curved spacetime. The straightest possible path. Falling. And that feels like nothing. What feels like something is the ground getting in your way. Pushing you off that straight path. Forcing you to accelerate upward. That's what you feel. Not gravity. The violation of gravity. The Earth stopping you from doing what you naturally would do. Which is fall. Think about this. Right now. You're sitting there. You think you're sitting still. But you're not. You're accelerating. Upward. At 9.8 meters per second squared. The chair is pushing you. Hard. Constantly. Accelerating you away from the path you'd naturally follow. Which is toward the center of Earth. You can't feel gravity because gravity is your natural state. Free fall is your natural state. What you feel is being stopped. The chair. The ground. Your shoes. These are the things that create the sensation you call weight. Remove them. Jump. For those brief seconds in the air, you return to your natural state. Falling. And it feels like nothing. Like floating. Like freedom. Let me give you the numbers. You weigh 70 kilograms. That's your mass. Sitting in a chair, the chair pushes up with a force of 686 newtons. That's 70 kilograms times 9.8 meters per second squared. You feel that push on your legs. On your back. You call it weight. But step on a scale in an elevator accelerating upward at 2 meters per second squared. Now the floor pushes with 826 newtons. The scale reads 84.3 kilograms. You gained 14 kilograms instantly. Your mass didn't change. The gravitational field didn't change. The push changed. The acceleration changed. That's all weight is. The force needed to accelerate you away from free fall. Change the acceleration, change the weight. It's that simple. That direct. Here's what Feynman would do in his lectures. He'd stand at the front. He'd say, I'm going to jump. Watch what happens to my weight. He'd jump. Right now, in the air, what do I weigh? 0. Nothing. I'm weightless. He'd land. Now I weigh something again. Did gravity turn off and on? No. Gravity was there the whole time. But while I was in the air, nothing was stopping me. Nothing was pushing up. So I felt nothing. Now the ground stops me. Pushes me up. I feel it again. Simple. Direct. Undeniable. Now let's test this. You're on the moon. Gravity there is 1.62 meters per second squared. About 1/6 of Earth. You weigh 1/6 as much. Why? Because the ground only needs to push you with 1/6 the force to stop you from falling. The falling happens slower. Takes less push to stop it. You feel less. But jump on the moon. While you're in the air. What do you feel? Nothing. Same as Earth. Weightless. Free fall on the moon feels identical to free fall on Earth. Feels identical to free fall in deep space. Because free fall is free fall. The natural state. What changes is only how hard the ground has to push to stop you. And here's the thing that haunted Einstein. If you're in a windowless room, you cannot tell if you're standing on a planet or in a rocket accelerating through space. Cannot. There is no experiment. No measurement. No test. They are physically equivalent. Not similar. Equivalent. This is called the equivalence principle. And it's one of the foundation stones of general relativity. It means gravity and acceleration are the same thing. Exactly the same. Weight is the feeling of being accelerated away from free fall. Nothing more. Nothing less. So let's bring this all together. Why can't you feel your own weight? Because weight isn't gravity pulling you down. Weight is the ground pushing you up. Gravity is pulling you toward the center of Earth. Right now. At 9.8 meters per second squared. But you don't feel that. You can't feel that. Falling feels like nothing. What you feel is the ground stopping you. Accelerating you upward. Pushing into your feet. Into your legs. Into your spine. That constant push. That's weight. Remove the push. Jump. Fall. Orbit. And you feel nothing. Not because gravity stopped. Because the resistance stopped. You return to your natural path. Which is to fall freely through curved spacetime. And that path feels like absolute nothing. The astronauts know this. They train in planes that fly parabolic arcs. The plane climbs. Then the pilot cuts the engines and pushes the nose down. For 25 seconds, the plane is in free fall. Everyone inside floats. Weightless. Not because they left Earth's gravity. They're still well within it. 30,000 feet up. gravity there is 99.5% as strong as on the ground. But they're falling. Nothing is stopping them. No push. No resistance. So they feel nothing. They feel their weight disappear. Because weight was never gravity. Weight was always the push. The resistance. The thing stopping the fall. And this changes everything you think about standing still. You're not still. You're accelerating. Constantly. The ground is pushing you upward at 9.8 meters per second squared. But you can't rise because Earth is in the way. So the push just continues. Forever. Accelerating you into the planet that won't let you through. That's what solid ground is. Not a platform you rest on. A platform that accelerates you. Constantly. Without motion. That's the paradox. That's the truth. You are forever accelerating upward while going nowhere. And that acceleration is what you call the feeling of weight. Feynman taught this to freshman physics students. He'd make them close their eyes. Jump, he'd say. What do you feel in the air? Nothing. That's gravity. Pure gravity. Free fall. That's what gravity feels like. Nothing. Then they'd land. What do you feel now? The ground. Pushing. That's not gravity. That's the ground stopping gravity. That's weight. He made it simple. Undeniable. You can't argue with jumping. You can't argue with falling. The sensation is clear. Gravity feels like nothing. Weight feels like a push. They're not the same thing. They're opposite things. So the answer to the question that broke your brain at the start is this. You can't feel your own weight because your weight isn't a property of you being pulled down. It's a property of being stopped from falling. Gravity pulls you. Constantly. Right now. But that pull feels like nothing. It's your natural state. What feels like something is the ground denying you that state. Pushing you up. Accelerating you away from the center of Earth. That push is weight. That resistance is weight. And the moment you remove it, the moment you jump or fall or orbit, weight vanishes. Instantly. Completely. Not because gravity is gone. Because the push is gone. The resistance is gone. You return to falling. And falling is silent. Falling is weightless. Falling is what gravity actually feels like. This isn't philosophy. This is measured reality. Every accelerometer confirms it. Every scale confirms it. Every astronaut confirms it. Stand on a scale in an accelerating elevator. Watch the number change. Your mass didn't change. Gravity didn't change. The push changed. That's all. That's everything. Weight is the push. Not the pull. And once you understand that, you realize you've spent your entire life feeling the Earth push you away from where you want to go. Which is down. Toward the center. Falling. The natural path through spacetime. You've never felt gravity. You've only ever felt the ground stopping you from obeying it. That's weight. That's what you call standing still. Constant acceleration going nowhere. A push without motion. A force without travel. The strangest feeling in physics. So common you never questioned it. Until now.